Okay, welcome everyone to this OpenNLP meetup number 15 in the deepset office. Thank you so much for coming to this office tonight. We have two speakers for the OpenNLP meetup. Unfortunately, the first speaker just called in sick this morning, but he agreed to give a presentation online, which is why we have the first presentation streamed about 15 to 20 minutes. Then we have some time for questions, and then we continue with the second speaker, which is here in person. And then after this presentation, another 20-25 minutes, you can again ask questions. And then, of course, we still have time to mix and mingle here. We have more snacks, more drinks. So please enjoy this evening. And now getting to this first presentation by Adrien. So Adrien is going to present a bit about Trafilatura. He will explain what this is. So I would say without further ado, Adrien, the stage is yours.
Thank you, and thank you for inviting me. I think it's best if we are not indoors tonight together, so it's good that we can do it that way. And I will start talking about what is it about. So basically, people need web data for large language models in order to get training data, in order to fine-tune or to do ARG on the content or on a query. And the basic idea is that if you can get better data, maybe your models will be better or cheaper or more efficient. So starting from this, the idea is there is a theory that HTML documents are great. And they're great in principle because they're the typical document found on the web. It's a clearly specified format with a number of tags, relatively lightweight. So it's not like PDFs. I don't know if you're familiar with text extraction from PDFs, but it's a lot messier. And you have also, unlike in PDFs most of the time, you have a semantic markup. That is, you can target elements based on the tag name, for instance, because a tag name named P paragraph will probably be relevant to you, and a tag name section, add section or whatever in the class name, or like you can use attributes of the element, you can use the names. It usually makes sense if the page is in English or if you know the language, and that is called scraping. And Trafilatura tries to do web scraping on a general basis. There is a problem first with downloads, which are available with Trafilatura. If you try to get documents from the web, like what's called web crawling, like you try to retrieve a large number of documents at the same time from a large number of websites, you come back 2 hours later and you get a different selection of websites. Like network errors happen all the time. Then you need to navigate on the web page to the desired section. Like maybe, for instance, in German, you don't want the Impressum, like you don't want the legal page. You want a page with actual content that's useful to you. How do you do this? It's unclear. And also websites change all the time. So which version are you to retrieve in the end or keep? These are open questions. You also have a series of problems with the web scraping. The theory that HTML is convenient is partly true, but you have a large number of HTML dialects. For instance, if you try to do web scraping on a Polish web page and on an English web page, maybe the same method won't be efficient in both cases because the syntax is different, like the series of heuristics that you developed are not applicable, or it will be the same if it's a page from 2005 and a page from 2025. Like HTML will have changed a lot during this time, and so it's hard to do it in a generic way. Also, you have a series of bloated pages, like not like this one. This is actually a web page. This would be pretty easy to extract the content. But news web pages are like you have links to article within the articles. You have a right column with similar articles. You have ads at the bottom. Subscribe to our newsletter, whatever. Like you will have a lot of content that it's hard to trace. We can talk about this later on the questions, but even if you do an approach like topic modeling, if the similar articles are basically on the same topic. So in what way is topic modeling efficient in that case? So there will always be like edge cases and problems. And even for human annotators, the problem is where is the actual content? Sometimes it's hard to annotate a data set because some people say, yeah, the date is part of the article, or you have a short introduction at the beginning, a short summary, it's part of the article. Some people say it's part of the metadata. Is the title, or some titles are part of the articles or not, and so on and so forth. And you also have a question of conversion, because in the LLM community right now, you have a lot of people converting to Markdown or TXT. This will probably not happen without losses, because HTML is messy. Like the HTML web page you want to convert maybe is not formatted correctly, so you need to clean it. You need to try to understand its structure, all of it on an automatic basis. It doesn't work all the time. Especially if you have embedded elements inside of embedded elements, and you need to like reconstruct the overall structure of the web page. So to try to mitigate these problems, like what people do is they get data from web archives. So in that sense, Trafilatura can do it, but you get more stable, fast downloads if you just download a bulk of data. You're not getting your crawler blacklisted, as it seems to happen a lot right now with large LLM companies. And you also get a limited choice of pages, but it's the price you have to pay. It's still acceptable, and it's the main approach right now. If you use a LLM for extraction, just as an aside, because it's a question that arises now, like, why do you do everything by hand? Or why do I write a series of rules or algorithm to extract data on a generic basis if I could just train a machine to do it? The problem is on which training data, like how do you annotate it? Like how much of it do you need? Is it cheap to run a file of 1 megabyte through a large language model? Because it will have a lot of bulk, and maybe you're interested in 3% of the document, and the rest you will just discard it. It won't be cheap. And also ML approaches can be disappointing. Like one of the packages used to extract data is called Dragnet. It's an approach like from the maybe 2015, 16, 17. It uses a regression model, so slightly simpler than current approaches. But they annotated 20,000 web pages, trained a model on it, and it still doesn't perform quite well. It's not bad, but it's not good enough. So maybe more pages are needed. Maybe you need to annotate 1 million web pages. Maybe it's something in the way the pages are sampled. Maybe they're too similar and you overfit, and then you miss something on another page. It's unclear, but ML approaches are not always the solution. That said, I have to say that my mental model and the way I wrote a software, it can probably be abstracted by a machine. It just hasn't happened yet, but it's basically possible, of course, that a machine can like do better than Trafilatura in 5 years or so. So what interests us today is in bold. So I will focus on this point, or maybe also if you have questions, I think this is the topic today. So what the software does is it provides a robust and configurable extraction. Like you have multiple output formats, you can extract the main text, the comments, the metadata, and it's more or less standard in the NLP and LLM communities as of now, because of its ease of use, its documentation, and I'd say its performance. And it's also used by other people because of the convenience function, like parallel processing, downloads, and so forth, but that's not the topic today. So how do you do this? You basically get rid of the noise and you go from the raw HTML to structured data. This is what it's useful for. You will collect data, like something like news aggregation or RAG. You will pre-process it, something that's also called article extraction and HTML to TXT. And then you will like read the page in your browser, in your terminal. You will. There are also people who are building podcast generators based on Trafilatura. So like you just extract the page and then the machine reads it to you. Everything's possible. But what interests us now is its impact on LLM. And here is a preprint from Penedo et al. From Hugging Face. And we can talk later about this. It's just to give you a general idea. The idea here is that if you take the wet data, so the wet data are the pages from the web archives with all the bulk. And if you take the pages that are extracted and that are, I guess in that case, TXT, or at least like the main text, you get a performance boost. I would also say you train faster, but here the impact is clearly that the model doesn't carry a lot of bulk, and so it's more efficient and it's better on the aggregate score. So how do you install Trafilatura? It's a Python package and command line interface. So you install it with pip. Then you use it in Python, for instance, like I show here. And you use it on the command line interface. You can use the help menu to give you an overview of all the options. And the output formats are CSV, HTML, JSON, TXT, and XML. So HTML is, for instance, useful if you want to display it in a browser afterwards. TXT, JSON, Markdown, I forgot, but you also have Markdown now. What interests us today is how it gets integrated into Haystack. So here is a short example of how to do it from Haystack. So assuming you've installed the Haystack package, you get access to a whole lot of document converters. And congrats to you on this, the team. Like, it's really neat, and you really get access to a lot of different formats and a lot of different document pipelines. And this is the one converting HTML documents. So it uses Trafilatura as its core. So you basically define a converter, and then you use HTML file as input, and then you can perform a series of operations on the documents as you would do with other Haystack processes. How to configure it, and what I will show now is both valid for Trafilatura and Haystack, so you can use it as extraction parameter in both cases. Sometimes you need to tweak the extraction a little bit. So there are two standard presets. For instance, if there is too much noise, you think the extractor on your use case is just outputting too much text, then you would add favor precision. On the other case, if you think parts are missing, it means maybe you need to prioritize recall. If you know what you're doing, or if you're interested in particular elements, you can select a series of elements, for instance, if you want tables or not. And the expert mode would be to add a series of XPaths to prune. So an XPath, it's like a way to find a specific place in the HTML document. And if you know that you have a series of pages and Trafilatura works well, but for your pages, you would need like this little bit more, then you can have a list of expression like this. So in that case, it would be like a P with an attribute, a paragraph with an attribute discarded, just for the example. Just a final word on the deduplication. So what you do is, once you have the documents, it's useful to try to find similar documents, because you don't want to process them twice. Among the things that you get from the internet, you have often like two versions of the same web page, or you will have pages that are quite similar in nature, because a lot of people are doing SEO, so search engine optimization, and just like putting a lot of pages in place that are basically random or like superficial content, and it's good to detect them. Like you have a lot of use cases. And the idea is that I use here SimHash. It's implemented in Trafilatura. It's just to start the discussion, if you want to talk about this. Like, it's not the most modern approach, but it offers a quick similarity estimation. It's cheaper to compute than other methods. And it has some basic understanding of element order. So like if the end of a document, it's always the same, like article like this, like more article on the same topic, whatever, then it will probably be the case in the hash that the last characters of the hash are the same. And it's included by default if you activate the metadata in the output. And I'd say it's useful for removal of near duplicates, but there are other solutions around. It was just to as an idea. And thank you for your attention, and I'm looking forward to the questions.
Yeah, thank you, Adrien. So I already saw one question in the audience, and of course also for the people online, they can ask questions in the chat, and then we can read them out. So let's start here, and maybe I repeat the question.
Yeah. How do you deal with content that's rendered as JavaScript and appears on the page late during the rendering?
It's about JavaScript, right?
Yeah.
Yeah. Yes, it's good point. I haven't mentioned it, but it's like it's your decision. Like for some pages, you have to include it, but in most of the cases, the bare text approach sees through the documents, because like most paywalls and whatever are implemented in JavaScript. So you even bypass a few paywalls if you just use the bare HTML document without executing JavaScript. It's also much faster. But there are some cases where it would be necessary. But here, like I said, the one use case is that people download documents, but the most people using Trafilatura have already downloaded documents and are just using it to convert them. So in that case, the JavaScript has already been executed or not.
More questions? Yeah, here's the mic. Go ahead.
Hi. So you mentioned that I didn't quite get the part with the XPath. You're actually trying to ignore XPath that you don't care about, or include them, and what's the mechanism by which you automatically try to exclude irrelevant XPaths in the run?
Thanks. Yeah. So there are two approaches. Like the software works on a combination of XPaths and algorithm. So like trying to see like the proportion of text, the proportion of link in an element, and trying to like make guesses on the document. The idea with the XPath parameter that's also usable from Haystack is that you could specify something. Like if you think the software has missed something, you can say, okay, I don't want to see this kind of element. So you can basically make the list of XPath elements, like the list of rules, more complete.
Can you explicitly whitelist and blacklist paths
Then, or can
I
you
didn't get
explicitly
it.
whitelist and blacklist paths then, or how does it work?
Yeah. So it's a blacklist.
Okay.
Yes.
But then what model is actually running under the hood to determine where the actual content is that you want to extract?
It's a combination of several models.
Okay.
There is a Python port of readability.js with a series of tweaks. Then you have the package JustText. And then you have a series of homegrown rules and algorithms. And the three of them are glued together. If you use it in fast mode, you just get like my rules. And if you use the full mode, you get a cascade of extractors, because like if the first one misses some content, or if you think, oh, it's not quite good enough, then another one is used, and there are three of them. So right now, like it's Trafilatura's content extractor, then readability, and then JustText.
Have you considered using like an ensemble method to stack classifiers? Because it's a classic classification problem, right?
Yes, but it's not, I understand, but it's not standard in the industry, so to say, because Dragnet used it, a Python package, and it just didn't work, or it didn't work well enough, so they dropped it. And there was another company after that, I think, who tried it. So yes, it makes perfect sense, but for some reason, a series of basically understandable thresholds as to what is the proportion of links in an element, like what's the depth of the HTML, where is the element situated, things like this. Like it's a series of heuristics. It's I understand it's not perfect, and from a computational standpoint, it's unsatisfactory, but it's the state of the art right now.
Okay.
We got several questions also from the online people, so maybe we can read them out.
Yeah, so a question from the online audience. Is it also possible to use CSS selectors besides XPath? And he also thanks and wishes you to get well soon.
Oh, thank you. No, you can't. I mean, yes, the parser, the HTML parser used, it's the most frequent one in the Python world. So it's LXML, and LXML understands CSS. But I chose to use XPath at the beginning, and I stuck to it. It turns out right now CSS selectors are more frequent, but it would be a lot of code rewriting to enable it. So far, I didn't do it, but it would be possible. It's just a lot of like changing the pipes in the software.
We can have another question from the online people if you want.
Yeah, we can have a question from here. I think you raise your hand first. So.
Hey, just curious about the precision and recall stuff that you mentioned. Is it related to the extractors, 3 different extractors that you were talking about, or is it something else? And like, how do you balance? Like, I understand there's a balance between precision and recall, but what is the workings there? Like, how does it work basically?
So the precision and recall, it's on my benchmark something about 0.9. Like to give you an order of magnitude. And for PDFs, it would be maybe 0.7. So it's more precise, but you always get like stray documents. What I tried to do, and I think it's where the approach was better in the end, is that I have a competitive benchmark, because my means were limited. I was doing it like alone or with one, two students. So I chose to select particular sections of the HTML, like but difficult one, like close to the article, but not the article. Because if it's far away in the document, it's easy to tell it's not part of the main text. But if it's just below or just above or in between, and it's NAD or something, it adds some complexity to the benchmark. So I have a benchmark with about 2,200 text segments, I guess, and like, yeah, nearly 1,000 documents, or maybe it's even more than that, but it's nearly 1,000 documents with 2 or 3 segments within the document and 2 or 3 segments without. And so with that, I can calculate, I can compute precision and recall, and you can look at the evaluation part of the documentation, and you will see the figures for this package and for other competing packages on my benchmark. And you also have links to other evaluations.
Oh, thank you.
Okay, I can read out another question from the people online. And the question is, do you see use cases of Trafilatura in place of basic web scraping, like Beautiful Soup, for lower level use cases, like non-LLM?
Yeah, yes, definitely. Like there are some people using it for SEO, so search engine optimization. There are people using it to build document collections from the web, like news monitoring, or like basically like before you ingest the documents in your database, you just pre-process them. And it's definitely an alternative way to do it compared to Beautiful Soup. Like in Beautiful Soup, you have the get text options, things like this, and it's a way to do it, but probably a bit better. It's just that Beautiful Soup will get a better recall because the parser is more lenient, but it's a small difference in the end usually.
Okay, we have one more question from the audience.
Basically, I was wondering, since you told about JavaScript execution, some website, when you try to extract information by scraping, blocks you by CAPTCHA or things like that. And since there are some models running in the background, I was thinking if you will be able to warn the user about that or not, or you simply didn't extract nothing if you get CAPTCHA or something like that. Keep in mind, I mean, what I have in mind in the, let's say that you want to extract information from some, I don't know, shopping website that usually don't want you to scrape information. So can you automatically, let's say, warn users about CAPTCHA and say, okay, I can't extract nothing, or you think it's too hard? Out of curiosity, basically.
I'm not sure I completely understand, but I'll try to answer, and then you can always ask another question. It's like so far, like I said, compared to Beautiful Soup, for instance, like the recall is not 100%. So you definitely have cases where like Trafilatura doesn't output anything or all the text. And but it's also what people say online about it. It's like in the end, it's not so bad because it's less than 10% of the document, or even less than 5%. And so you can live with it, or you can always use another parser as a backup parser. So it will tell you something is wrong. Like if something is wrong with the HTML, like if you get an empty document, it means HTML is not confirmed, or the website just returned like a lot of boilerplate and an empty page. So for instance, if with your shopping page, it would be like nothing is found because there was just like a generic page from the shopping CMS. And in that way, I would say it's better, but in the end, I try to strike a balance between precision and recall. That's measured by the F-score, for instance. But in general, like I think it's good not always to if you don't always output text. Like there are approaches where you want to find something, whatever the cost or what you find. But if something is basically wrong, or if the page is nearly empty, or if it's just pure boilerplate, usually you won't get an empty document.
Okay, with more questions, but for the second speaker, you can already come to the stage and sit up. So you go first.
No, sure. Okay, thanks. Do you have a way how to handle websites that are protected by authentication or require authentication, like passing a bearer token in the header, something like this?
You can pass cookies in the header, but like Trafilatura's options are limited because it's open source software, and I don't think it would be reasonable to enable like complex bypassing methods, because it would get banned pretty fast, and the main problem would be that you would need to change it all the time. So for maintenance reasons, I didn't do it. But if you look at the documentation, there is a page about what happens if you have no content, and then you have suggestions. I try to maintain it, but you can look around for ways to mask yourself as a browser, or to bypass authentication. Like there is software for this. And then you can use Trafilatura. The idea is that if you think the download utility is not enough for you, then you just use another one, and you just use Trafilatura to extract the content.
Okay, so just to complete my previous question, so let's say that you manage to bypass authentication or solve the puzzles of the CAPTCHAs, then you can pass through Trafilatura directly the document, the HTML extracted, right?
Yes. Like in Haystack or in Trafilatura, like it's independent. Like it's just the download utilities are for convenience only. They're not state of the art. The extraction is state of the art.
Okay, thanks.
All right, then thank you so much, Adrien. And Adrien also said he will stay for a few more minutes in the chat in Zoom. So if people online still have a question, feel free to ask. And then let's thank our speaker again.
Thank you.
And then let's get to the second talk. So we have Michele here with us, who will talk a bit about OpenWeb UI and Hayhooks. And this is then also related to Haystack a bit. Yeah, you can turn the camera on and share the screen so that the people online can also.
Is that correct?
Yep, that's the correct one.
Okay.
Can also see you while you present. So then we can get started in a second. So what Michele will be showing is a live demo, and also showing all the steps you would need to take to deploy your Haystack pipelines yourself, together with Hayhooks and OpenWeb UI. And looks like you're ready to present.
Yeah.
So yeah, looking forward to your presentation.
Yes.
Not shared yet.
Ah, this one. Okay, so sorry. Let's over here. Okay. Ah, right. Okay. Okay.
We don't see
So there's an issue here.
Okay, let's see.
Switch the primary. Yeah, duplication.
How is yeah, but I don't know how actually with this mirror. This one. No. Text. Display set. Start mirroring and touch screen. Okay. So I guess that I need that. Okay, now it should work.
Yes, looks good.
Okay. Okay. Okay, so hi there, I'm Michele. I'm from the open source team, as Julian said. And now we want to talk about deploying LLM-based application using Hayhooks, which is a tool that we made as an open source team to help you deploy Haystack pipelines. And we will talk about the integration with OpenWeb UI. So briefly, wanted to see, this is basically the GitHub repo of Hayhooks. We just released the latest version now. All that I will say will be explained here in details. And basically, so you can go through all of these. And basically, our goal is to reach here. So integrate a Haystack pipeline with OpenWeb UI and have also a chat interface. So go back with our presentation. What is actually Hayhooks? Hayhooks, the idea behind Hayhooks is basically to simplify the process, as I said, to deploying Haystack pipelines by turning them into fully functional REST APIs. The idea is that we want you to avoid the configuration part, which usually is, it can be quite a mess and case specific. With Hayhooks, you can also wrap your Haystack pipelines with custom logic. So the end user will have the full flexibility to modify the pipeline behavior, of course, as much as it's needed. And it's also able to generate API endpoints that actually comply with OpenAI chat completion APIs. So this will enable as well the integration with OpenWeb UI, but since it will act as an OpenAI backend, it can be also used with the Haystack component, OpenAI chat generator that maybe some of you already know. And yeah, the idea is since Hayhooks will take care of the deployment part, as an Haystack developer, you can focus more to your core pipeline logic instead, of course, of creating custom fast API application or whatever. So as I said, to give you the maximum flexibility, you need to write this pipeline wrapper, which is basically an implementation of a provided class, which has three methods. One to set up, initialize the pipeline, one to run the pipeline in API mode, and one to run the pipeline like, when it's integrated in a chat application. So when it receives, for instance, the user messages as an input. Let's see an example. This is basically the minimum pipeline wrapper that you need to write. So there's not much code here. In this case, we need to define a setup method, which basically initializes the self.pipeline variables. In this case, we are using a pipeline which is also part of the templates from Haystack, which is called Chat with Website. It uses actually Trafilatura under the hood and basically enables one one user to ask a question to the extracted content from a website. And there's also that run API method. As I said, this is to run the pipeline in API mode. So you will define the inputs. In this case, there are a list of URLs and a question. And you can decide how to run your pipeline. So if, for instance, you need to pass other parameters, you can simply change the signature and the return type. What will happen, I'll describe soon. Basically, for make the previous wrapper running, you need to add the YAML definition, because basically here I was loading this, and the pipeline wrapper.py in a directory. Then Hayhooks comes with a CLI to help you deploy the application on the running server with basically one command. But don't worry, later I will show a brief live demo with all those information. And basically, Hayhooks will save your files and validate your wrapper implementation, dynamically create an API endpoint, which basically has pedantic inputs and outputs, pedantic models, sorry, for inputs and outputs of your pipeline according to the input arguments of the run API signature and the return type that you decide. In the previous example, we had URLs, a list of URLs, which is basically a list of string, then the user question, and we return a string as well, which is the answer. Why we decided to follow this path of implementing a pipeline wrapper? Because basically you have the total freedom about how to initialize a pipeline. In the example that I show you, I was loading from a YML. But you can also declare it as inline code. You can load from somewhere else if you store your pipeline somewhere else, or you can use Haystack templates. Then, with the run API method and the run chat completion method, you basically can customize at max the execution logic. So if you want to include some custom code in it, you can. And of course, as I said, it enables the OpenAI compatible endpoints, so you can integrate with interfaces like OpenWeb UI, with also the support of streaming the responses. Okay. So, as I said before, if you implement this other method that is called run chat completion, Hayhooks will automatically create the OpenAI compatible endpoints that you probably know. Basically, the implementation is quite straightforward. In this case, the signature is fixed because this is a typical, the typical list, the minimal list of parameters that are incoming when you do a chat completion request, for instance, using the OpenAI client in your application. And then, yeah, as basically the run API method, here we extract the question from the user messages. We consider only the last one. So this is a simple utility to extract the last one. And then we run the pipeline returning a string, like we did in an API method before. Then we also, since of course we created those OpenAI compatible endpoints, Hayhooks can be used as a backend for OpenWeb UI. And it's quite straightforward to configure it. You simply fire up OpenWeb UI, and in the settings, you simply set it as an OpenAPI backend, and that's it, basically. The connection will be verified, and you can interact with your deployed pipelines using chat. So basically, as I briefly show you, you can ask a question, and you will see directly the answer. In this case, the answer is all at once because there's no streaming support in the function that I showed before. If you want to do streaming responses, using Haystack, of course, under the hood, we provide a streaming generator utility that can ease this. So basically, the implementation is more or less the same, but you need to wrap the pipeline execution in this streaming generator. So you pass the initialized pipeline in the setup method, and then, of course, the run arguments that you want. And basically, the effect is the streaming effect. So the chunks that are getting response will be streamed to the OpenWeb UI front end. About the deployment in Hayhooks, since it's basically an HTTP based API application. We also provide some basic deployment guidelines about how to deploy it effectively. Of course, there can be single worker deployments where if you, for instance, do mainly I/O operation, or you don't have an high number of requests, or multiple workers deployment if you have a CPU-bound pipelines and you expect a high number of concurrent requests. We are also working about examples about how to deploy Hayhooks in more complex environments. So not, let's say, on AWS VM, but for instance, using Docker Swarm or Kubernetes. Okay, before we jump to the demo, we wanted also to know that next week there will be an event here where we will do a breaking down to the deepset R1. Okay, so I will show you briefly a demo of what we just saw. So basically, I hope that you can see something. Let's try to. Okay, so this is basically an empty folder. I simply loaded, I preloaded some examples with that pipeline and the needed wrappers. So we basically had this is basically the implementation of the wrapper that we want to deploy. So we have the setup method where we load the file that is also here, basically, the chat with website, the YML definition of that pipeline, which is also available as a Haystack template. But in this case, just to show you that you can customize what you want, we will load it from this folder. Then there is the run API method that simply execute the pipeline. And then the chat completion. Basically, it's all implemented. And then we also will have a streaming implementation, which is basically exactly the same, but it's using that utility that I was explaining before. Okay, so, well, at first we create briefly a virtual environment and we activate it. Then we will install Hayhooks. We also activate it here, will be needed later. Okay, then with Hayhooks, you will have a CLI, as we said before. It takes some time at first due to some imports that need to be cached, but okay, now you have it. And of course, each command is quite well documented, so you can follow the information in the README of the repo, or of course, using the help here. Let's run the server. Okay, and now let's try to deploy a pipeline. Here I have already the command. We will deploy first the, let's say, non-streaming example. And it will fail. And at this point you say, why? You have the error, but sometimes only the error message is not very clear, probably. So in order to show the full stack trace, we will configure Hayhooks. This information is all explained in the README. Oops. We need to enable this, which will show the full traceback. So if you have errors while deploying, now they will be clearer. So let's start from scratch, of course, because I want to show you everything. So, okay, now we have the full stack trace, and we know that Trafilatura is missing, basically. So we need to add to our environment. In the future, we plan to create a virtual environment for its deployed pipeline, but for now, you will need to add the needed dependency yourself. So now the pipeline is deployed. And okay, if you go here, you can say that this is basically the documentation of all the endpoints. and we have our endpoints, which actually support the same parameters that were basically part of the signature of the run API method. And we can try it out. So you can, let's say, use the SSI website, which is basically only text, so it's easy to play with it. Okay, so we have the response here, and it's working. Then, no, sorry. Let's make the server running. Of course, with the CLI, I can also see that this pipeline is deployed and active. And now I want to deploy the other pipeline, the one with streaming support. So let's do that, and it will succeed because, of course, I already have Trafilatura installed, so no more dependency issues. And now we have 2 pipelines deployed. So let's try now to see the integration with OpenWeb UI using the streaming one. So let's go to OpenWeb UI. I load it on. I'm running it locally, but you can easily run it from a Docker container. And oops. Here, as I said before, we need to check that the integration is okay. So here it's already done. You can verify the connection. Basically, verifying the connection means only checking the /models API, which usually on OpenAI is the one that make you choose between 01, 03, and so on. So here it's okay. We can go back there, create a new chapter. We simply select the streaming mode, and then we can say who found the SSE. And it will get the response. One thing that don't know if you already noticed is that instead of the API mode here, we have only one input, and we have only the messages. So in that case, in the wrapper, I had to hard code the URLs, of course, because it cannot be passed by only the question can be passed and can be extracted by the messages. So the URLs here are coded here. So I can ask questions, for instance, about Redis, about Haystack, about SSI, but not, of course, on other website. And basically, that's it. Oops. Sorry. Okay. Yeah, basically, this should be everything. As I said, we will work in order to give you more options to to deploy in a real environment. For instance, this is a single process application, basically, but we also support running the pipelines with multiple workers. So if you have more than one worker and you want to deploy a pipeline without using, let's say, a lot of resources with tools like Kubernetes and so on, you can also, if you have a VM with more than one core, you can use all the available cores easily. And yeah, basically that's it. If you have some questions, just ask.
Oh, we can start if there are any questions here in the audience, or for the people online, please post the question. We can start.
Thank you very much. It's super interesting. You said it's providing also recommendations about cloud deployment, right? How to deploy it. Maybe you can give a brief summary, or like what would be your recommendations? And also another question, I saw that you have thumbs up and thumbs down. Where does this feedback go if the user clicks on it? Thanks.
Okay, so to answer the first one, basically, we already have Docker images that are working, but since basically we resumed this project after a while, we are reworking them. So we will provide, for instance, some example to deploy in a managed Kubernetes environment like AWS ones, or maybe even a Minikube local, just to give you some examples. But in the end, it's simply a Kubernetes deployment instance. And you can have, in this case, a single worker with a single pod, multiple workers with multiple pod. You will define a load balancer in the front. I mean, there are many options, of course, to do this deployment, but you can also deploy it on a VM. If you don't have the Kubernetes instance, you don't want to waste a lot of resources, or you simply don't expect a big load about the pipelines endpoints. You can also use single workers or a multi-core VM, which usually is cheaper. But yeah, best is we will probably provide examples of end-to-end examples of basically from, I mean, we can use this pipeline or one that which will be more CPU bound and deploy in different environments. Then I don't get the second question, sorry.
Yeah.
You can.
Yeah, so basically in the UI you have thumbs up and thumbs down, so for feedback collection, but this feedback needs to be recorded somewhere. And like, do you provide maybe like database, like a local SQLite or something instance for it, or how are you managing this feedback, or is it not?
Okay, no, at the moment it's okay. At the moment is it is a feature from OpenWeb UI, but it's sent to the backend, but at the moment is ignored. It's more a thing to the OpenWeb UI frontend itself. Actually, what you say, it's interesting. Maybe it can be used from the pipeline point of view. We can for sure deep dive on it and see if it can be of any use. Maybe let's say that you have the pipeline that gives some answer, but you need to collect feedback as well. So you provide the interface, but you want also to collect the feedback. So that's a reasonable use case, in my opinion. Yes, thank you.
More questions? Okay, then we can read out one from the people online.
So the question is it possible to enable stream response using the OpenWeb UI pipelines repo? And stream response with underscore.
Using the OpenWeb UI pipelines.
Repo.
Yes, it is. Probably you can still use the same utility that we actually provide. So in the demo, I was mentioning the streaming underscore generator method. And if you're already using the pipelines repo from OpenWeb UI, you can also use this utility. We basically follow a very similar approach to implement this part in Haystack. What we didn't like much about pipelines is that it was basically uncovered by any test and it breaks quite easily. So yeah, we tried instead to, for instance, if you don't initialize the set.pipeline variables in setup, in Hayhooks you get an error, which is reasonable and understandable. In pipelines you don't. So I didn't try, but I guess you can, since streaming generator is tailored to the streaming generator utility is tailored to Haystack pipelines, you can use it also in any kind of other wrapper that expect a generator as a return type with chunks, so with strings basically instead. So the answer is yes.
Thank you.
And to check the documentation to be 100% sure.
And there's also another question from the online audience. You mentioned the OpenAI endpoints. Are there any other LLM API endpoints available, specifically Ollama?
Yeah, I mean, Ollama is doing exactly the same approach. So since a lot, I mean, there's not only OpenWeb UI, I guess there are a bunch of other front ends that basically expect to talk with a backend which has the same shape of the OpenAI APIs. So yeah, we basically mimic this approach, but of course more tailored to Haystack pipelines.
All right.
Yeah, more questions? Okay. If there are no more questions, then this concludes the presentation part of the meetup. Of course, feel free to stay here, stick around, have a chat. It's also a special meetup because we have many deepset people here today. In fact, the whole team behind Haystack, the open source engineering team at deepset, is here. Some of them you can recognize because they are all wearing the same jacket, but there are more. And you can also celebrate tonight with us the Haystack release version 2.10, because just a few hours ago, yes, we released Haystack, and I think we are all happy to chat about all the new cool features in this release. All right, thank you.